All right, we're back. We are COMP123 in the summer 2019 semester at Centennial, and we're week 10. I guess we're week 10, but we're lesson 10. This is officially lesson 10, part 1 of our broadcast. Last time we were doing lesson kind of 9, right? By the way, if this is wrong, I'll fix it, right? If it's the wrong lesson, I don't know if I don't know if this is actually part 1 or if this is actually part 4. But later on, when I put it up on YouTube, it'll be fixed. So what I want to talk about today is a couple things. One of them is, for this first part, is exception handling. So let's go into that. I have a PowerPoint that I put up on eCentennial for you about exception handling. Let's talk about that. All right, so I want to really talk quickly about this, and then what I'm going to be talking about in the next recording is all around shifting between forms and how to do radio buttons a little bit better to help you with Lab 10, because people are reporting that Lab 10 is really hard, right? And actually it's not really hard, but you have to know what forms are and what you're doing, right? So I have to explain that with you because I never had a chance to. So this is your explanation for Lab 10, and it'll be in the next video. So first, let's start with a quick lowdown on exception handling. So what is exception handling? So imagine when we have a lot of errors, and you might have different kinds of errors. You might have syntax errors, right? Syntax error is going to be caught before compile time, right? So syntax error. And then you might have a logic error, and that gets caught when you do some debugging, right? But sometimes there's some errors that happened because you're trying to do a calculation, or you're trying to access memory, or you're trying to load a file, or something that doesn't exist, right? And so you get other kinds of errors, and these kind of errors break your code. It'll actually take down your application. And so what these things are called are exceptions, and what we want to do is we want to be able to handle them or catch them and then deal with them, right? So we have this idea that it's an error that is unexpected that's going to be thrown from some kind of behavior that your program is doing, right? And unexpected behavior happens because the computer does not know what you want. It only follows your instructions, right? And there's a bunch of different kinds of exceptions you can have. There's on one page. Here's all of them. Actually, not all of them. There's many here. There's many more than this, right? But these are some of the most common ones. For example, an arithmetic exception, right? For example, when it comes to casting and conversion, you might have an index out of range exception, which is very common, right? Or maybe you have some kind of I/O exception when you're trying to open up a file or close a file that's not open, or something like that. And then there's, of course, the famous Stack Overflow exception, when you, call a function that calls itself, do some kind of recursive call, or an endless loop, or something like that keeps calling other functions, and then you lose, you don't have enough memory. Then you might get an out of memory exception, or you might get a Stack Overflow exception. So these exceptions aren't bad, right? When I say the exceptions, these are errors that are unhandled. And what we want to do is we want to understand why these errors are happening. So we have an exception class that can help us with that. So the exception class is called exception. And all of the exceptions we just saw they're systems. They're made by C#, basically. C# programming language has all these different basic exceptions. And then we can use them to identify problems within our code. Also, we should use them as just in case. Just in case, the file's not found. When the user's trying to open the file, what happens? Well, we want to have exception handling around that. So again, we have this idea of a system exception when we divide by 0. Here's a divide by 0 exception, right? Now we're just talking about different kinds of exceptions and how to handle them. So here's the first kind. So we have an exception of some code. We have miles driven and gallons of gas. And we also have miles per gallon, which is a rate. Anytime we have a rate, miles per gallon, a velocity, acceleration, it's some unit over some other unit, okay? Whenever you have a unit divided by something else, if you divide by 0, you'll have an error. And this is what this is showing here. You have a couple of things here, and I take miles driven over gallons of gas, and if in the read line my gallons of gas that the customer or the user enters is 0, then we have, it'll generate an exception. And here's the exception. It says, divide by 0 exception. Attempted to divide by 0 at miles per gallon main, and it might tell you even the line. So how do we handle this stuff? Well, we have to handle the exceptions, of course, with a try-catch. So there's two types of blocks here. There's the try block and the catch block. And you guys have seen this before, but we're going over it more formally, so you've seen it in officially. You've talked about it a little bit. There's also another block we're going to talk about called the finally block. Try, catch, finally. And we'll talk about what those things do. So here's an example. Try, catch, triple X. Oh my God, this should not have been written here. Triple X is like weird. Why did they write triple X? Okay, it means any exception. So try, catch, some exception, whatever that exception is, and then an exception instance, right? Whatever that exception instance is. By the way, the exception instance is a friendly name for that exception, an instance of the exception that's being generated. So you can call the exception instance E. You'll see that as a very common thing, right? I don't like it. I don't like that E. You can call it error, right, or exception. That's more normal. If you want, you can call it Tom. It doesn't matter what you call it, in other words. It's your name, whatever you put there. Please don't call it Tom. I'm not an exception. All right. But let's go to the next one. So try, catch. And then what happens is if we're going to use try, catch with that example, that silly example with miles per gallon and so on, here's my try block. So I'm trying to divide by this number, miles divided by gallons. And if it fails, it's going to trigger the catch block. All right. So first it tries to do this, and then if it fails, it does this. And then you can see E. Again, I don't like the E, but you could use E. And then it says like, okay, miles per gallon is equal to 0. We set it to 0. And console write line. Well, we don't have console write line. We're going to use something else today. We're going to use a debug write line. Okay, debug.writeLine works for Windows applications. Right, we write inside of the output window. We're going to see this, where we don't have a console, right, at all. We haven't generated a console. So again, we're going to debug.writeLine, and we're going to output, hey, you attempted to divide by 0, and it's an error. Okay, that's what it is. Or if this worked and this wasn't 0, it would work and ignore the catch block. Okay, that's how it would work. So now if you notice, it goes here, and it says you attempted to divide by 0, and it won't break your code anymore. It'll error out normally, right? Your code will execute, and you won't have a problem. So the exception class, you can also override. It overrides the ToString, so you can always go exception or e.ToString. But it also has something called message, which I prefer to use, right? And what you can do is e.message, and message is already a string. So that's the better way to do it, although you could say e.ToString. That's fine, e being the error. And so then you can print out the type of error that you have. What is the error? You know, as an example. So again, you can also have as a way of catching multiple exceptions. In the first case that we did before, let's go back up to that one. So go back up to the code. This catch exception, the exception is the superclass of all other exceptions, right? So here what we're doing is we're catching all exceptions. And there's a bad use case for this, okay? A really bad use case. People use exception handling, try-catch, to catch errors in their code so their code keeps working. I mean, without doing anything about it, right? So code is not working, try-catch, right? Now it works. Bad, right? Because later on, it's going to catch you, right? So please don't do that. However, this is a catch-all, so it catches all exceptions, every one. We don't care what exception, it'll trigger this one, okay? Here in the other option, we want to find specific exceptions. For example, we can have multiple catch blocks. Each catch block can catch a specific exception, and what we can use initially, before we do any kind of refactoring, remember I talked about the way I do code, which is I do some kind of sketch for my application, then I make my user interface, then I make it work, then I refactor. I don't refactor until everything works. Why? Because you're going to work for a company, and they're going to want the application now. They don't want to care about refactoring, right? They want it working. They want you to show them a proof of concept. You have no time to do perfect code, right? Make it work, and then go back and fix it. Okay? Now, there are some companies out there that'll tell you, slow down, test-driven development, a different way of coding, which is you make a bunch of tests, which we're going to get into later on, maybe next week. Make a bunch of tests for something that doesn't exist. It's going to fail first, and then write the methods to make it pass. Okay, that's a different kind of way of doing things, and then refactor. Okay? So this kind of a red-green refactor methodology for test-driven development. Here, we're not talking about that. We're saying make it work first, and then after it works, refactor. So here, let's suppose I use the catch-all, catch exception, not catch specific exceptions. And then I print out what the exception is. I found out what those exceptions are, and now I catch those specific exceptions. Great. And if I catch anything else, or if it breaks again, that's another error that occurred that I need to do something with. Now remember how it works. Try to do this. If it doesn't work, tell me what type of exception that's causing the problem, and then do something for each of these exceptions. Maybe something different. If you're doing the exact same thing, then use the catch-all. Use just catch, right? If you're doing different things, then do, again, divide by 0 or whatever the type of exception is you want to catch. So here is an example where we have the second type. So again, going back up, this is capturing the first type, where result is equal to numerator over denominator, where denominator is 0. So the first type of exception is going to be triggered because it's going to divide by 0. Okay? However, notice this, 13, right? Number 13 is also going to generate a second exception down here, index out of range, because there is no 13th element. Right? 13th element, not going to happen. That's wrong too. So that's this error, this second exception. So you can have two different types of exceptions in a try-catch, a try-block, right? Now, guys, that would be very bad. I mean, this would be like multiple errors that this is catching, right? Typically, it's not because we want to catch errors. We want to handle errors, all right? Catching errors and doing nothing about them is not what we want. All right, so we caught multiple exceptions, again, or you can use one to catch everything. I don't recommend using that. Here's a really bad piece of code. If you ever see something that looks like this, all right? By the way, try-parse, we've done try-parse before. I didn't teach you how to do try-parse, I just showed you how. But try-parse is part of exception handling. Instead of using a try-catch, you can do it in a try-parse. And a try-parse is like one line of code, where try-catch would take like many lines of code. And if you're only doing a very simple, kind of a try-catch, like you're parsing something, it works best if you use try-parse instead of try-catch. It's a little bit less overhead. But here's something really bad. If you ever see code like this, an if, and then no curly braces, that doesn't work for me, guys. I'm sorry. My coding style doesn't allow it. All right? If you see this online, and if you see no curly braces with an if statement, I mean, it's almost like I want to take that number equal to default value and put it next to the if as one big line. That's what I want to do, because it's better than putting it underneath. Because now I'm thinking that this thing, maybe I just came from programming in Python, and I think that this is okay to put another line with no curly braces. Or some other language doesn't need curly braces, like Lua or something else. Guys, don't get into this habit. Use curly braces to denote a code block. It's better. Next, so here's an example of try-parse. You can see that this could be like what try-parse looks like, right? If it was me, and again, they're trying to make a try-parse to give you an example of what it does in the back end. But if it was me, if I was coding this, I probably would start with false, not with true. So instead of Boolean what's successful is equal to true, I'd probably put something like Boolean what's successful is equal to false. I would say it's going to fail, all right? Prove to me that this try-catch is working, and if it's true, then what's successful is equal to true would be put inside this try block. The catch block, I wouldn't put anything because it's already false, right? And then I would return if it was successful or not. That's me. That's what I would do, differently than this, okay? Both ways work differently. And notice I'm catching a format exception, E. Why? Because I'm getting strings. I'm getting an input string. And I'm trying to convert an input string into a number, which, if this input string is an alphanumeric character or something like that, it's going to fail. All right, so there's also something called the finally block. So we have try, which is basically you're trying to be everything okay. you catch, execute something, right, as an example, and then you want something else to happen in the finally block, regardless of whether you were able to be successful in your try or you failed in your catch. However you did it, you need an extra piece of code to respond to this other piece of code. Think about it as a callback function. I always like thinking about it like that. Like, you have, I want to try and do this, and if it fails, do this. I want to do this, and if it fails, do this, and if it passes, fail or passes, do this too. That's what finally is. Finally always executes, okay? So why would I want that? So here's the example. I try and do something, I failed to do something, okay, I'm going to do something anyway. That's what this does, right? And a good example of that is when you have some kind of I/O. I open up a file, everything's okay. I try and read the file, it fails. Uh-oh. I go to my try, or my catch, I tell you that there's a file read error, and then I go to my finally to close the file, if it's open. Why? Because otherwise the file is open, it's going to generate another error if I go on later on. If I, for example, I want to try and open it up somewhere else in my code, it's going to generate another open error. It's already open, right? So I close it off here with my finally. Yes?
If you put like inside the catch, you put like a break, it still goes to finally?
No, you don't put breaks in this case. This is not one of those. This is almost like, try catch is almost like doing an if else.
Mm-hmm.
But sometimes you can't do an if else because if else would cause an error as well.
Mm-hmm.
Yes?
So, in JavaScript we do it if in this try. Like if this is that, then throw this.
Yes, you can do that.
How does this throw something to the catch? I still don't get that. How does this?
It doesn't throw to the catch. It goes to the catch. So if try fails, if your try block fails for whatever reason, you fail to execute any code in your try block, it'll trigger your catch block. That's what'll happen.
So
at whatever point it fails. So for example, if I try to open a file, like the first line here, open a file, everything is okay. It didn't trigger the catch. If I try and read the file and if it's wrong, it goes to the catch file right away. It doesn't execute the other stuff.
Oh, so you put your whole code in the try.
Everything's in your try, and then if you can do it, good. Now sometimes what we want to do is we want to put less code in the try, and we have multiple try catch blocks. Specific things we want to do.
Yeah.
Like for example, I could try to open this file first by itself and then catch, and then try to read this file first and then do this, and then try to place the file data in the array and then do that, and then try to calculate the average and do that, and then try to display the average. I can do different try blocks if I really want to. A little bit wordy, but you could if you really want to. If you really want to be specific, like you want to do all the things. But then you got to think about this, right? If you did that, it would still fail overall because the whole operation would be failed, right? You want to display the average. The only way you can display the average is if you open the file, right? So one thing kind of depends on the other thing. So it's better to put it all in one block. If they're independent operations, then yes, you can make your own try-catch block for each one of them. All right, so how about when you have a method that throws a try-catch, it throws an error. Here's a method that could throw an error, right? I have some kind of double array, price, where I have some values. And then what I do is I have this display price method that I pass in an integer item. Where it could go wrong is if I pass in a reference to the wrong item or an item that doesn't exist. Right? For example, 0, 1, 2, 3, I pass in 4. 4, there is no fourth item, so this would cause an error, an index out of range error. Should I do it in here, the try catch, or should I do it out here, the try catch? What do you think? By the way, either one is okay. The difference between if I do it inside a method, it stays in the method. If I do it outside the method, then it tries to execute everything else first, right? So it tries to execute all these three things, and it's executing the method as if it's one line, right? Whatever the result of this method is. However, if you really wanted to, you could put a try catch in here too. It's up to you. I wouldn't do both. One or the other one, but not both. And then, of course, once you catch it, it can tell you it's an index out of range error, and you can do it that way. Okay, so I'm not going to go too much into this too much more. There's also something called a StackTrace, which we're not going to get into, but basically what this is this. Here's a bad situation. I've got a double tax rate. I've got two elements, 0.06, a tax rate of 6%, or a tax rate of 7%. Okay, good. And I got a cutoff of 20%, let's just say, right? So the maximum tax rate is 20%. Or actually, this is 20. I don't know, this is like, I don't know, 2,000%, right? That's what it is. 0.06, 0.07 cutoff, you know, something crazy. But actually, this is the price cutoff. That's what this is, right? So we say something like this. We say, okay, I'm getting my price into this determined tax rate, and then I make an integer, a local variable called subscript, right? And a local variable called rate. And if my price, whatever my price is, right, is less than equal to the cutoff, so it's not as big as the $20 price range, then my subscript will be 0. Use a tax rate of 0.06%, right? 6%, right? Otherwise, if my my cutoff is greater than $20, my price is more than $20, use 7%. So tax them more if the price is more somehow. I don't know. That's a weird thing. But now we have a problem because it says subscript 2, but there is no subscript 2. Subscript is 0, 1, 2 doesn't exist, right? So this is an error. And also, look at this if-else statement. My God, my Turkish friend, would you write like this? Would you? Would you write like this code? If-else with no curly braces? Oh my God. In Python, but not here in C# and not in C++. Please don't do it. It's bad, right? And then, look at this. I try and pass my subscript. This is okay, but I pass it in here, and then it causes an error, an index out of range error. This is a bad situation. So really what's going to happen is when you call this determined tax rate, it's going to generate an exception, and what you need to do is try catch it. That's all you're going to do. Okay? You can also write your own exceptions, which is the next section, which we covered kind of in generics. Generics, you can make your own exception, and it can throw its own messages, its own exception types. For example, negative balance exception. This is the the idea that you're going to throw a message. That's what it's going to be. You're going to pass that message back to the base class, which is the exception superclass, right? So whenever you have a negative balance, you're going to throw back bank balance is negative, which you can't have. Okay? So how does this work? Well, we check. We say that here's my bank account as an example, and we're going to get a balance and set a balance. When we're trying to set the balance, and if the value is less than 0, then guess what? The balance is going to be negative balance, and so we're going to throw a negative balance exception. That's what's going to happen. Here we generate the new balance, the new exception, and there we throw it. When we throw the exception, this causes our code to break. Okay, our code breaks. And then what we need to do is catch the exception somehow or handle it. Okay? So the throw keyword breaks your code or generates the exception for you, and then what you can do is you can use try-catch block to catch the exception and handle it. For example, like this. I want to have my account balance. I'm using my setter to set the account balance to negative. This generates an exception, throws an exception inside the class, and then what I do is I catch the exception here and I write in that it is a problem. And that's your own exception class. And I'm not going to talk about rethrowing because basically you're rethrowing the exception after you make one. So that is exceptions in a nutshell. You can read more about exceptions online. There are a ton more and really good reasons to use them, and we're going to use them later on when we do file handling, database access. There's exception handling we use in many, many places. And by the way, for most times for those things, they're required. C# won't let you write some file handling without using an exception in many cases. All right, or try-catch block, I mean. So that's it from now. I'm going to stop recording this one, and we're going to get on to the next part, which is the meaty part, more Windows Forms stuff for you guys to help you with Assignment 4 and Lab 10.